Hey, can you folks hear me? I'm not really sure if the audio is set up properly. Starting bar. The profile picture looks familiar. Is this someone who I know? On a Friday night. Good to see you folks. I haven't done this before. This is my first live stream. In the sense, I've been on other live streams. I've never done live stream on my own. So the audio is low, is it? Uh, is it okay now? Or should I get something else? One moment, I'm just trying to figure this out. Hey, can you hear me okay? How about this one? Hey, Ramesh and I went to college together. Oh, nice. Thank you. It's not super clear. Hey, let me just like get the mic out and then try out the default one. Let's see how that works out. Hey, sorry for this thing, folks. Like the audio software is not something that I'm familiar with. Trying to figure this out, but I'm really sorry for the trouble with the audio. I believe there's also lag. Okay, thank you. All right, I believe it's. I'll give it a couple of minutes. Uh, yeah, I was saying Ramesh and I went to college together, so it's really good to see him again after a long time. It's been a while since we met. This is great. Where are you folks come from? Like, which part of the country or which part of the world are you joining from? And if you and any Rust developers here? Do we have any Rust developers here? Yeah, I don't know Rust. I hope like we have a mix of folks that are familiar with different programming languages. Let's see how this is going to turn out. I'm going to give this one more minute and then we'll start. Alright, let's get started. I'm Raghunath. I run this website called legacycode.com. I am a solo founder. I have been working on legacy code stuff for a pretty long time now. For example, I used to consult a lot of clients. So one of the responsibilities of my job was to go in and look into different kinds of code bases and try to understand what is happening. And some of these code bases were like pretty huge. Some of them were like really old. And like they say, necessity is the mother of invention. I have been trying to understand code bases for quite some time now. I remember writing my first tool in 2019. So 2019 is where I started building small little tools to see, okay, can I understand this a little bit better? And I've been building tools for quite some time, especially around parsing languages, looking into Git history, trying to sort of intersect both information and see if it gives you useful insights and as such. And with the advent of AI, things have changed a lot, and even a lot of people find it hard to catch up with the AI. Like I do write code pretty much every day, and even after a week, I don't really have a lot of context about what I've built. So it's become a really hard problem to solve for, and I believe it's not just me, and everyone is experiencing this a lot. So today's talk is about is the same thing, right? Like let's see how do we go get a code base. So what happened? Uh, so today's topic is about how do you approach any code base, right? Like even code bases that you're not really familiar with, and can you really get up to speed in a very reasonable amount of time that's expected of you, or even sometimes even a lot faster. I have an agenda prepared for this event, so I'm going to like resize my video, and I'm going to show you what are all the things that we're going to look at. So this is the agenda. I hope we have time to finish all of that. These are the list of tools that we're going to use. I'm pretty sure like most of you would be familiar with some of these. It's a text editor. This is a tool that counts the number of lines of code. We're also going to use a Git GUI client. We'll not use the command line for Git. Then I'm also using Codex app. This is currently my favorite. I also hope you folks use coding agents. And if you have favorite coding agents, just like drop them out in the comment so that we'll know. And then this is the last thing, is an open source project that we built recently. So that's what we'll talk about. I'll share all the links in the description of the video later, so you can go look at it. So this is what we will do. So we're going to look into Rust's code base. This is OpenAI's coding agent. It's a command line tool version of the agent, and this is the code base that we have. We're going to take a look at this and try to see how much of it we could understand today. Then this is how it's going to look like as a very high level overview of what we have. I hope we'll have enough time to cover all of these, but let's go ahead. So the first thing that I want to understand is this. When you folks have a new code base, what are the things that you try to do? Like drop them in the chat box. I'll take a look at it, and I would like to see if you have some interesting ways of actually dealing with these kinds of code bases. So here's what I do usually. So the first thing that I do is when I have access to the code base, I clone it, and it's usually on my machine. And then the first thing that I do is use this tool called clock. It stands for count lines of code. And then I run it inside the code base. So basically what this command does right now is going to count the number of lines of code in the code base. And then we are saying, okay, only count the number of lines of code for the files that are tracked inside your version control system, because you don't want to track the what do you call it, like binaries or generated files that will give you incorrect information. And when I do that, it takes a little bit of time, but eventually it'll give you a table, a nice table like this. And if you look at the table, at the bottom you see there's about 429,000 lines of code, so that is about half a million lines of code. And they also do like a distribution based on languages. So Rust is the predominant language here. It's about 300,000 lines of code. And then you have like some JSON, probably test data, configuration information, then various other things, right? Like Markdown is documentation and all of that. So it's not, it's like if you work on monoliths, you probably are not a stranger to this kind of code bases, right? And I'm sure like a lot of people work with a million lines of code or more. So this gives me a rough idea of like what the code base looks like. Like you have a sense of okay, like how big is this code base? And the more you keep doing this with clock, the more you sort of develop this familiarity on how these code bases are, right? So this is the first step I do with any kind of code base. I just want to see the language composition. I also want to see how big the code base is, and that helps me build some familiarity about the code base that I'm dealing with. So this is the first step I do. And the second thing is like what I believe everyone does it, right? Like you probably go take a high level look at the code base, like how is it structured, what are all the folders that you have. For instance, you know it's a CLI application, there's like a bunch of stuff that's inside. Then you have Codex, RS, so I believe that's called Rust, and then you have like a lot many modules over here, right? So there's like a lot of stuff here. You could also use Git information to find out like what's going on and whatnot, right? Let's say for example, okay, switch to what would I do? I have no idea how to get rid of this. I hit something. Okay. So these are some directories, right? You probably go start looking into code.rs because this is where like most of the stuff is, right? And another command line utility a lot of people use is probably copy relative path, and then you do a tree dot that prints something like maybe tree dot or tree app server, for instance. So that also gives you like a nice little tree overview which you can also browse in the code base, right? Like inside your command line or whatever. So that's one way to get started with. But when you are looking at a file tree like this and when you're expanding it, you basically end up seeing a list of files. Like it's not very helpful in this case because you know it's just like a list of files and you really can't do much with the list of files, right? So going forward, let's say for example we want to look into the app directory, right? Let me go back to the root of the project. Yeah, this is the root of the project. So the first thing that I can do is, let's say I want to explore one of these folders that I'm interested in. Let's say I want to look into like apply patch, for instance, right? So I look at apply patch, it just gives me a list of files, but it's not very helpful. So what you could do is you can actually take the relative path of it and then run clarity show, and then you can include the path, and that is going to generate a graph for you, right? So this is a graph. This is quite huge, right? So it's huge, and I also see a lot of text files in it. So what I'm going to do is I'm going to run it, and then I say include extension, and then I'm going to exclude text, right? So this is a lot more nicer. It's a lot more simpler because you're just dealing with the Rust files here. All those text files are gone away. This is basically a GraphViz document, and this is something you can go ahead and visualize in your online GraphViz viewer or any other plugin extensions. But where it gets more interesting is you can actually say -u and it'll give you a URL that you can open in your browser, right? So I'm going to go ahead and say open dollar, so that this gets, okay, this is opened here, right? So now let me just move this over here. Now what we did was we took this directory, which is apply patch, so that's the module that we are interested in, and then we created a diagram that shows what's going on inside, right? Now I'll talk a little bit about this graph and how you can, you're supposed to go through the graph. You see a lot of boxes, and these boxes have different files in them, and each of these files have a Rust extension. So the background of each of these boxes are determined by the file extension, and it's helpful when you are looking at a diagram because you know which files are forming a group. And here you also see the ones in green, but then they also have the RS extension. And usually when you say RS, even though it's a Rust file, they are marked in green, which signifies that these files are tests, right? And perhaps someone with Rust knowledge can tell me why is there a dependency between a production file or like a module file and Rust files, right? So this is usually like unexpected, because when you're visualizing code bases, you have production code and you have test code, and test code usually depends on production code. It's not the other way around, right? So this relationship is sort of interesting. I want to know why. If you know, just let me know. And you also see like a bunch of these other pink color files. These are markdown documents, so you know, like inside this folder we have 3 markdown documents. We have a git attributes file, we have a bunch of Rust file along with some tests, and then you have other files, probably a build file. I think this is the Rust build system, and this is probably like the general build system to build the entire tree, right? So this is one way to look at the module. We can go ahead and look another module that could also help. Let's say let's I don't know, backend client, not that big. App server. This is looking at app server. Here I'm going to go look into app server. And then we have this diagram. No, this is such a large, it's a pretty large diagram. Okay, this is a pretty large diagram, and I see 3 networks. There is this one is disconnected, and then you have another network that is pretty huge, and then we also have a third network that is pretty huge. So we have 3 different graph networks. Now I'm curious if this module or if this directory has more than one module. So if you look at app server, you have source and you have tests. Okay, so that makes sense because I believe like the source dependencies are separate, and the test net dependencies are very, very different. Let's go take a look at this again for a moment. Right. So what's going on? Yeah. Now, if you look at this diagram, there are a few things again. Like if you notice, the first thing that stands out is some of these files are of the same color. So all the Rust files are white in background. The different build files are different color based on their extension. You have a documentation file that has a different thing. And what's interesting is this new cyclic dependency between these 2 types, right? So there is some amount of shared functionality and type definition between these 2 files. We can inspect what they are later, but that's not the kind of dependency that you typically want to have in any kind of code base, because if you contrast the graph, you have the lines flowing from left to the right, right? So all of these arrows are flowing in one direction, and if the arrows are flowing in one direction, it's a lot more easier to reason about the system than to have relationships that go back and forth. And one of the things that you can say just by looking at the graph is the fact that if a system is well designed, then most of the arrows will be flowing in just one direction, so from the right to the left. And this is a relationship that we'll probably have to look into because it's a structural problem, right? We're not going to look at it right now, but eventually we will look into it, right? What else do I want to talk about here? And the second thing that I want to talk about here in this situation is what kind of things are usually placed on the right versus what are the things that are usually placed on the left, right? Now, on the right side, if you look at this one particular example, you see there are only incoming dependencies. There are no outgoing dependencies at all, right? So this error codes, it does not depend on anything else. It's just being used by everything else in the system. But if you look at the lib.rs, it doesn't have anything coming inside, right? So it has all outgoing dependencies, but like there is no incoming dependency. Neither is good or bad for a few reasons. I'll tell you why. And if you take this thing and then if you reason about this in terms of a RESTful controller, for instance, if a lot of people are writing code for the server, then you would have also written a lot of endpoints. And if you look at the entire flow of the controller, you would see you usually start from a controller, then it will go to like some part of a business logic, then it goes to a repository, then it goes to a database, and then that's there you have your entities and all of that, right? So when you design a system, systems that interact with the external parts of the world, those are the ones that usually are on the right side. Like say for example, if you're a mobile application developer, then your high level component would be your screen, because it also does a lot of orchestration, and in order to do that orchestration, it has to know too many components inside the system, so it will always be on the right side of your graph, left side of your graph, right? And the components on the right, those are like small components, and then they are easy to reason about. And taking this logic a little bit further, you'll see that the component on the right side are small and are easy to reason about. So for example, in this case, we say, okay, this has error codes, and ongoing messages has some information about error codes, right? And you also know configuration API also has information about error codes. Your message processor has information about error codes. And then you have your transport layer, that is also like transport or Rust, that also has like information about error codes. So this system, when you look at it, this does a lot of side effects, and error handling is a major part of this system, right? And as you go towards the left, right, and then you have ongoing messages. So what else is happening inside? So this has some kind of event loop. That's what's happening, because you have event handling here, you have message processors, you have ongoing messages, and you have the thread state, you have message processor over here. So this basically does something related to a messaging queue. That's what I would guess from looking at this diagram, right? And since you are starting from the right side of the system, you can build smaller mental models really quickly, and then as you move towards the left, you can reason about complex systems. So that's the idea behind the structure of the graph, right? And even if you look at this one, you see all the arrows are flowing in one direction. So it's fairly like a well-designed system. That's why like the arrows are flowing in one specific direction. And if you also notice, these are either used to test things within this system, or they're getting exported by or they're getting exported outside of this package for use by other systems. So that's why you don't see any dependencies coming in, right? So this is all very, very linear. So that is one more example, and this is the second diagram that we've looked at. You can go ahead and keep looking at different kinds of diagrams to understand what is going on. But before we go further, I just want to summarize the things that we have seen right now, because these are important on the next step of the process. So one is like the color of the files, then not having cyclic dependencies is important. Then you also see how low-level components are usually on the right side of the system, and then high-level components are on the left side of the system. So if you're trying to understand the system, you start from the left, and then start from the right, and then you slowly move towards the left, building your mental model. And in well-defined systems, you'll always see arrows flowing in one direction, right? So that is one more insight that you have right now. Now it's all theory, but you also have to know how you can go use this in the real world, right? And all the commands that I was showing right now here, these are all manual commands. This is how you can go ahead and use Clarity, but it's pretty much a very cryptic, it's not very easy to use this workflow. So therefore, the way how I go about using it is I use it with a coding agent. I recommend using a coding agent that has a desktop version. Either use Claude Code Desktop or what do you call it? You could use Claude Code Desktop, or you could use Codex app. They are really good candidates. And the way how you use it is you install Clarity, and then you say Clarity setup, and then it sets up, it adds instructions to the agent file, and that's how it does it, right? So now we'll try to see how we can do this by just asking the agent what to do. Let's go and look at the GUI client for a moment. This is not necessary. So this is the main branch. And the first thing that I try to do is, when you have a new code base, it helps to get a good sense of what has been happening in the team in the recent times, right? So you know, like, which parts of the system are being evolved, who is working on what, that sort of information. Now, this is the Codex app. I've opened it in Sublime Merge. And the next thing that we're going to do is we're going to explore this code base using the coding agent. We're not going to do this manually by typing commands, but we'll just go talk to the agent and understand what is going on. So this is the Codex code base. Now, before I start, before I start working with the Codex agent, I have not set up Clarity inside Codex. So what I'm going to do is I'm going to give it a initial prompt for in-context learning, and then I will go ahead and ask it to do stuff, right? For example, now there is a prompt. It just has usage instructions on how the agent is supposed to use Clarity, and Clarity is already installed on this machine. Now I'm just going to say, hey, can you give me the last 10 commit messages from this repository, starting from the oldest to the newest? Give me 10 commits, only one commit at a time, and for every diagram that you show in the commit, also show me the commit message. And only go to the next diagram when I say next. Okay, that's the prompt that I've given to the Codex app, and this app is currently running is looking at the Codex API. So let's see what's going on here. All right. So it has created it says add CWD as an optional field to threads or list. So that's a change that has happened to the system. So CWD, I believe it's current working directory. And then if you look at this, you have a bunch of files like mostly JSON, again more JSON, one TypeScript, Rust. There's some documentation that got updated. There's some Rust. There's a test, and there is another Rust, and then there is another documentation. So if you look at it like this, gives us pretty much some clue about where to start looking. These blocks are not connected with one another, which is fine. But now that we have a clue on where to look at, we'll just go look at the commit and see what's the 10th commit. I'll just find out the commit ID here. Commit. Then I go here. Yeah, so this is the commit that they have done. So it's mostly configuration files have changed, like JSON. If you look at it, like it's all a lot of duplication and it's mostly configuration. And there's some information here about the markdown. So this is something to do with the model context protocol. So that much I know. There's something to do with the MCP and what else? There's something. Okay, they've added a new filter for current working directory, and restrict results to threads whose session current matches this path. Okay. So there's some work. I don't have to understand everything. What I'm trying to do is to build familiarity with what is happening with the code base. That's what I'm trying to do. Now we'll go back to our agent, and then we'll say next. I'm going to create another diagram. Yeah. Okay, there's nothing more here. More approval scenarios. So approval scenarios probably has something to do with this one, right? Yeah, something to do with permissions, sandboxing, all right, that kind of stuff. And they have a bunch of tests in the same file. That's why they're not showing up on a separate file, but it's all Tokyo tests. Okay. Okay, we'll go to the next one. So there's some configuration with MCP. There's something happening with permissions and approvals. And then this one is also interesting, something to do with app loading logic. Okay. Yeah, this has something to do with the app server thing that we were looking at, because I still see the message processor. Don't show. This is also like not very interesting. Go to the next one. Okay. This one says there's a cyclic dependency within the same file, which is incorrect because it's impossible, or like it's okay to have cyclic dependencies within your own file. This is likely a clarity bug. And if you have time, I'll show you how we can fix this one. But let's go ahead to the next one. This is a bug in the tool. Yeah, there is execution policy something. Okay, what's next? So most of these are like single file changes. This one does not have any tests in it. I don't know why, but it sounds important. Like execution policy feels it's an important part of the system. They're also talking something about restrict models is rules. So I wonder why there are no tests. But that also makes me curious, because this one sounds important, looks important, but then there are no tests. In this case, I'll probably go take a look at the commit E6E4. So here, E6E4. Yeah, this one. Okay. Oh, so this one is if the model says a bad role, don't show it to the user. So they're basically filtering some of these patterns from the user so that it does not run Python scripts or bash commands, PowerShell commands, does not access the environment variables. Yeah, so it basically doesn't, dynamic script execution is what they're trying to prevent. And now it makes more sense, because even though it sounds important, I was wondering why did they not add any tests, and now it makes sense because they just have to add a list of commands that the agent should not access or ask the user to run on their machine. Alright, that sounds good. Okay, what's this one? And this is like a lock Rust tool chain, so basically something related to the build. So these are all unrelated files, so I can just like safely skip this one. So that's done. Okay, so now we have another diagram. So this is an interesting diagram. Like so far, of all the commits that we have looked at, this is the first one that has like a fairly good amount of commits. There are like 14 files. And now you see, if you go back to the editor, you see 14 files, and this is just a list of files. And it's really hard to understand what is happening where, right? So you know there's a new file, but apart from that, there's nothing else that we can reason about. But at least now you can look at this and then say, okay, there is something interesting that is going on here. And so what is going on here? They say they've done something with the network proxy. They've structured policy signaling and attempt correlation to core. Okay, I don't understand much of that. But what I can see is whatever change that they did has spanned across multiple parts of the system. Like they made changes to the state, they made changes to the runtime, and that has cascaded to everything else in the system, right? Interesting. So usually you also have to understand that the impact area of any change, when they're done on the right side of the system, very few files change, right? Because they're at this edge of the system. But if you notice something changes on the right side, which is if your low level components change, they have the cascading effect because a lot of consumers are using these components. So that's why they cascade. And then a lot of files change along with it, right? So this is one of the things that you can know. The impact depends on where the change is happening. If the change is happening at the low level component, the chances of them cascading is very, very high. For example, if you're working on database persistence or network calls, and if one of these changes, especially if you're going to change an entity object, then that will rip through your entire system, and that's also a lot of frustrating, because if you miss requirements, then that change becomes so frustrating and so hard to make, right? So we see there's this thing, but then there's also this one cyclic dependency inside the diagram, right? So that cyclic dependency is interesting. And the next thing I would do is I probably go ahead and look into what is going on with the rest of the system and try to reason about it, right? So for here, you have a proxy, and then the proxy is not just for the HTTP transport layer, which means if you want to add other transportation layers, it's still possible, right? That's why they have one level of interaction before the actual HTTP proxy, right? Then they have something to do with network policy, then the responses and a bunch of stuff. If you want to take a look at it, you can actually go look into the actual code and then see what changed. Like if I were to look at this code, and if I'm someone who's supposed to review this code, I would first go ahead and look at the state and the runtime, because that will give you a general idea of what is going on in the system, right? So here, the first file I'll go look at is I'll look at the state file. And this is block total. So this is just one line of change, and they're probably trying to collect stats on how much traffic gets filtered, or like violations are attempted. Then the next one is another file, which is runtime, I believe, right? So this is the runtime. Yes, correct. So runtime also has like a bunch of stuff that's going on here. So this has like codex network policy violation. So this also has to do something with security. So they are logging a lot of important information, that looking at attempt, the decision on the connection, source port. So this very detailed information capture happening at this point, and they also have like a host block reason. Interesting. So when you instead of looking at a list of files, because a lot of time when you're looking at a list of files, it gets really confusing. So that's why it's helps when you start looking at actual concrete stuff, right? So this is one part, and the way how you can do this is, I was just going through the commits in a sequence, but other ways to do this would be, you could say, okay, I am working with Ramesh, for instance, right? You could say I'm working with Ramesh. can you pull all the commits committed by Ramesh and then just like list all those for me to review, right? And that way it'll actually help you look at only those commits that belong to a particular user in your team, right? And if you're reviewing a PR, you can also do reviews commit by commit and then try to see how the system is evolving over a period of time. So those are some cases how you can go do this. And the other way you can also use it is you could say, remember looking at these directories here. You can actually ask the agent to look at each of these modules for you, and then they can tell you like which ones, and you can just like navigate, or you can give it these relative paths, and the agent can draw those diagrams for you, right? So it becomes a lot more easier to look at the diagrams rather than typing the command manually. It is super helpful when you're using the diagrams. Now, I don't think we have much time left, so I'll go and show you something else more interesting. So, seeing diagrams is one way to do it, but a lot more interesting things can be done with Clarity. Like I'll show you what happens. Now let's say, yeah, this is what it is. Okay. So now we are inside the Codex Codebase, and if you notice, we have this cyclic dependency between the state and the runtime, right? So usually what this means is there are types or functionality that is defined inside these files, and both of them are actually using things that are inside, right? And when you spot these kind of cycles, it's often very hard to diagnose when you're using an IDE, but when you're using an tool like Clarity, you can look at them when as they happen. And the second thing that you can do is actually you can fix them, right? For example, I can ask the agent, why is there a cyclic dependency between the state and the runtime? And now it's going to look at the diagram, and then it's going to tell me why there's this cyclic dependency happening between these two files, right? So it's an import level thing, and it says it's trying to investigate, it's trying to look at the previous commits and see why there was something that introduced, right? So it says because there is network policy constraint, which is a type, and there is a function, right? And then these other things, config state, network proxy state, and blocked request, these are defined inside runtime. That's why state depends on it. So there's like a cyclic dependency is not that big of a problem. But now for you to fix this, since these two depend on something common, which means there is a missing entity in this case, right? Now, I want you to watch at the right side of the window, because now I can go ahead and say, can you break this dependency by extracting the common functionality and types into a different file? Now what's going to do is the agent is going to make changes to the Codex Codebase, and it's going to try to do something, and then we'll wait and see what it is doing. It's going to reason for a while, and then it'll start making changes. And once it makes the changes, you can still go ahead and review it in your IDE. But on the right side, what happens is, as the change happens, Sanity will render those changes in real time for you. So when the agent is working, you can only see files are getting added or removed, but you don't really cannot reason about the relationship between those files, right? So now 3 files changed, but why am I not seeing them here? Okay, sorry. This is the window. Yeah, correct. That was the wrong window. So now if you look at this, the agent has made change, and now you see lib.rs is also depending on types.rs. I'm missing something here. Yeah. So correct. So now the agent is making changes, and then you can see that the way how it is changing, right? So earlier there was a runtime between, there was a cyclic dependency between the runtime and state. But now, since it has extracted all those relevant types to a separate file, then the import statements across um, the module has also changed, right? So who else is depending on types now? So librs was also using types. HTTP proxy was also using some of these types. Obviously, runtime and state were depending on each other, and then socks5, some socket thing, is also depending on it. So now, the moment you try to break the dependency, a lot of things have changed right now, right? I'll just wait for the agent to finish doing its stuff, and then we'll see what is happening here. Yeah. So it's still making changes to the test. It's running tests for us. Yeah, so it's making changes. Once it made all the changes, it says like the thing is not there. Now I want to regenerate the diagram because I want to compare the diagram with this one, right? So this is the one that is like we want to make sure that we have not made this one worse, right? So I would want to go ahead and regenerate this diagram as a baseline against the changes that we have right now, right? So what I'm going to do is I'm going to say one, list all the files in the commit. And then I'm going to say redraw the graph diagram using the list of files from the current working directory. Now, the agent will try to get all the files that changed in the previous commit that I showed you, this one, and then it's probably going to give us a newer diagram. Yeah, so it's redrawing the diagram from the current working directory. It's using the right command. Yeah, so this is how the diagram looks like. Can you draw the for? Now I'll just like put it right beneath it so you can see how things work out. And then again, you see all the arrows flowing in one direction, which is again great news. So this is one way. So what you're doing, so this is the older diagram, and this one is the newer diagram, right? The next thing I'll probably do is also go and this one does not include types, so I should ask it to include types. So that was my mistake. But then you get the idea about how you can actually change structure in the code base. And most of the times when you're making structural changes like these, the compiler itself becomes a test, because if there are problems in the code, then it won't compile, right? So these kind of structural changes are fairly risk-free. You could just like, if you have tests, it's even more easier. Now at the bottom of the screen, you'll also see there is a arrow, so it captures all the changes that are happening in the system as your agent is working on it. So you could just say, okay, like what happened first? Like some of these were extracted from this class and then they put in the new file, and then what happened? And then runtime also started using those types. Then what happened? Then you had state. What was it previously? Lib runtime. Okay, state is something new. So state is also starting to use the types that are extracted, and then gradually reason about how these things changed, right? Like, and then like there probably a search and replace across the rest of the files. That's what happened. And again, like there's a counter that keeps changing, so you can actually track all of these stuff about what is happening, right? So this is one use case where you can actually refactor and watch what is going on, right? The second thing I would do is I'll show you how you do this using development. So this is one way you are refactoring and you're trying to see how the system is evolving and like asking questions and going back to the agent, all of that. The second thing that you could also do is I'll go to clarity. There are like a few bug fixes that I want to make, but I did not make them because I want to show those to you. So now we're going to fix some bugs in clarity. One of the bugs is I'll show you the bug. If you look at Codex, it says clarity here, right? The diagrams the labels say clarity, but the project is Codex. So this is a bug in clarity. Now we're going to fix that bug and see what happens. I'm going to start a new session, say the clarity project, and I say, why do the mermaid diagrams have hard-coded name in them as clarity? Each project should have the root directory's name. Can you fix this? So now I've told it that there is a bug in clarity, and I want to fix I want you to fix that issue for me. And it's going to search because I told it it's in the formatter, mermaid formatter thing. So still searching. Okay, let it search and okay, I'll wait. I think we have some time. Yeah. I know some folks are running these agents for several hours. Sometimes they leave it overnight. I'm curious to see how they do it. Of course, they're burning a lot of tokens and all of that. But I'm pretty curious to see how their workflow looks like. Like my agent runs for like a couple of minutes, like maybe 4 minutes, 5 tops. I haven't been able to give them tasks that are like so huge. So now if you look at it, so it looked at the show command. Now it's also changing the test for the command. Of course, it's part of the label generation is part of the show command, so that's where you type clarity show and then you give it parameters and it generates diagrams. Okay, that makes sense. That is how you're supposed to change it. But I would also want to see changes to the formatter because the mermaid formatter also has changes. Is it going to tell me it has fixed everything? I'm sort of curious. I'll just go take a peek. What is it doing? Okay, it's adding a lot of bunch of tests. Okay, instead of this hard-coded value, it has replaced it with the repo label. Okay, not bad. Okay, I thought the problem was with the formatter, but the formatter is probably just displaying the information that's handed over to it. And since we're inside clarity, I can build a new binary and then ask it to regenerate the labels for me. Now it's done. Can you generate a diagram for uncommitted changes in the code base? I queue the message for a bit and see what happens. Okay. Oh, it's running the old command. It's going to show me the old diagram. Oh, I'm sorry. Oh, this is clarity. Can you build a new binary and show me the changes in coding agents / codex? It's Of course, like if you're going to regenerate the diagram inside the same project, then it's not going to show because it's still showing clarity correctly. I don't know if it's correct or not, but if it's running against codex, you will know. Yeah. So we just ran the commit against. Yeah. So we regenerated a diagram, and then it says codex here, which is the right answer. So this bug has been fixed. But then now, after we made this change with types, now there is a cyclic dependency between lib.rx and proxy. That is something that will go ahead and look at it. This one, can you commit? And just commit changes inside the codex codebase. So this is one more use case. So one is like you're using it to comprehend the system. The other one is to modify existing features, bug fixes. And the last interesting thing that I want to show you is this stuff. I shipped this feature that you're looking at, the live feature in the morning. And there are some places where it's very interesting. Like say we're going to look at this one. I don't remember what feature I was building, but the first change was creating a README, then was creating a command, then started testing the command, then it created a bunch of other things. This was a pretty big feature, I believe. So now you see you have tests and other things that are part of the system. Then again you have more changes, and eventually we settle here, right? So this is helpful because you can actually see how the system is evolving as you build it. So that helps you build a mental model of what is happening inside your system. Sometimes we don't understand what is happening, and we have zero insight into the design of our systems. With at least this way you can understand what is going on. So nowadays what happens is whenever I'm working with an agent, I usually nowadays, in the sense like since yesterday, I would just like look at these diagrams and then see what is going on. So the first thing is there's a transform command, then there's probably a entity here, then there's a test. That makes sense. Then there's one more test that goes to the projection file, then it creates something else, and the command depends on the projection file. Now there's a command there. But now my question would be, why are these two pieces disconnected from one another? So that is something that I would want to find out. So in that case, I would go back to the Git client and then try to understand what went there, right? And even when you are reviewing AI generated code, like I said, you still start reviewing from the right, which is basically the low level components, and then you move towards the left, where you have higher level components here. Here it's basically tests, which is good. But that's how if you decide to review, because sometimes when I find that the diagram is reasonably good, then I'll probably go test the application or test the command line, and if everything looks good, then I would sometimes check in the code without even reviewing it, and I'm pretty comfortable with doing that. But that's sort of an intuition that you end up developing after you keep doing this and keep repeating this enough number of times. Yeah, so to wrap this thing up, I believe we've looked into a few things. One is how do you limit the amount of information that you're consuming, and can you be smart about it, which means looking into only folders that belong to your team, and like not, instead of looking at it as a file, use like a visualization tool and read the low level design of the system to use it. So that's one way where Clarity can help you. You can use it in a manual way, or you can use it with a command line. It's an open source project, so it's free and all of that. You can just use it if you want to. Then you also saw how we were like restructuring this code. So now we find something here like that's shared between these two. I'll go look at the file, and if I want to break it, I'll break it. And if the design is not optimal, you can still discard all the changes, because it's pretty cheap to use AI for modification. So restructuring is something that I do a lot, because it not only helps me reason about the system, but also if I want to introduce tests, then I can be very strategic about where I want to introduce tests. Like say for example, if I want to introduce tests for network policy, I could just go ahead and then make sure it's decoupled well and test it, right? So in this case, even if you want to look at how testable network policy is, it has only one dependency, which is runtime, right? So if it has only one dependency, then it's a lot more easier to test in isolation, right? But as you move, components on the right are usually like the low-level components are easy to test because they don't really have a lot of dependencies. But if you want to test lib rs dot for instance, then you will end up doing a lot of mocking, right? So when you look at the diagram, one of the things that I also try to do is take platform or framework related code and then try to extract as much code as possible away from these framework and platform classes, because the platform and framework classes are usually very hard to test and you probably need integration tests, right? So when you look at the diagram, it makes a lot more easier to make these kind of deductions and these kind of choices, but without visualization becomes very hard, right? So this is also like restructuring and refactoring is one use case. I also pretty much use it extensively with AI generated code because I want to have a good idea about the system that I'm building. So usually I keep regenerating these diagrams and I start looking at the Clarity Watch panel to understand the system, and it's pretty much helped me reason about and decide how these systems are built. Yeah, you could, again, there's like a lot more use cases. You can use it for PR reviews, you use it for unfamiliar code bases, there's a bunch of stuff. So that's all I want to talk about today. I don't know if we have enough time for questions, but I can wait. Thank you folks for okay, someone said Ralph loop helps running agent for a long time. I haven't tried Ralph loops, but I've been hearing about Ralph Wiggum for quite some time now. But that's something that I'm not very familiar with, but I would love to give it a try and see how it looks like. And thanks for you folks for showing up on a Friday night at 8 p.m. And please remember to give me feedback on the session. So there's a QR code that you can look at. Let me know what you think, and if you need any links that are here, and I'm accessible on social media, so you can reach out to me anytime if you have something, if you want to grab coffee, whatever. That's all. Thank you for being here, and I hope to see you again next time.